Hi, this tutorial is going to look at our Excel calculator for central tendency, variability, and position, and I'm on the central tendency tab. And in this problem we're just looking at some hourly wages for some employees. These are the employee numbers because names are being anonymous here. And you'll notice that the wages are sorted from lowest to highest. So that's intentional because in order to calculate a median, we need to look in the middle of all the range of values here. Right? So you can see that when we look at this 22, that's the value that's the median. If we click on this box up here, it'll show you the formula that's being used. And basically what that formula is doing is just looking at the two middle values because we have an even number. There's 8 employees. So we need to go to the fourth and the fifth position and get the average of those two, right? So 14 and 16, which are in cells B7 and B8, right? That's what the formula says. And then divide by 2. Okay, so that gives us the median score, right? All right, so, well, actually, we've got a problem there. We've got to add some parentheses. So we have order of operations problem without those parentheses. I was wondering why that was so high. So the median is 15. Okay. The mean, you'll see, is simply the sum total, which we have automatically calculated there. So first of all, let's look at the total. If we click on that, you'll see the formula is sum, and then a range of cells, B4 down to B11. Range in Excel uses the colon, right? So B4 through B11 is B4 colon B11. And that can be used, that can be calculated automatically if you just use the auto sum feature here. You just click that, and then this kind of dashed line that's moving says, are these the cells you want to look at? And you can just select the cells like that, click enter. All right, so the mean is simply the total of all the scores divided by the sample size. There's 8 in the sample, right? 8 employees. So you see the formula here is just B12, which is the total divided by 8. Okay. We looked at the median already. The mode is just the most frequently occurring score. So you can see that 12 is the only score that appears more than once. So that is the mode. So we can compare those, and you can see that the mean and the median are pretty similar to each other, which when we start studying skew, that's an indicator that this is not very skewed. When the mean and median are roughly equal, you have what's called a normal distribution typically. If the median is greater than the mean, then perhaps you have a left skew. If the mean is lower than the median, you might have a right skew. So that's something we'll look at later. The next tab here is the frequency class table. So instead of individuals, we have groups here. So in this particular problem, it says a company produces Christmas toys, organize its factory workers into 4 groups. We're calling those groups protocols here. So groups 1, 2, 3, and 4 are there. And it shows in the table the number of toys that are being produced by these groups. So it says, as shown, what follows measures of productivity over a period of 1 month indicate the workers in protocol 4 were the most productive and they made the most toys. Right? And so using this table, we can see the number of toys that were produced and the number of workers that were in each of these groups. Okay, so group 1 there, protocol 1 had 10 workers, they made 20 toys. Group 4, they made 22 toys and only had 8 workers, so very productive group. So the weight is simply multiplying the number of toys by the number of workers. So the score times the sample size for that group. All right, so it has an Excel formula. You can see if I click on the box up top here, it's multiplying cells B5 and C5. And then the same is happening below that. And now you don't have to type these things manually. Once you have one of these, you can copy it and then paste it into those other cells. Okay, then we have totals down here. So this is just going to be the sum of this column. And this is also the sum of this column, right? D5 to D8. And the reason we took those sums is so we can calculate an average. So you can see the average number of toys across groups was 18.2, and the way that was calculated was by taking the weight, so that 856, and dividing it by the number of workers total, which is 47. So D9 divided by C9. All right, so that's how you get an average from a frequency table, which is a little different than how we found an average for individual level data. Right? You don't have to use any weights when you have individual level data. So grouped data, we have to treat a little differently. So this next one shows us how to calculate the variance and the standard deviation. So in this problem, we have 5 convicts with prison sentences in years. That's what the sentence is. There's 5 here. So prisoner 1 got 4 years, prisoner 2 got 5. You see prisoner 5 got 40 years, so they're what we call an outlier. Their sentence is much longer than the others in the group here, which is going to have an effect on the mean. You can see the mean is 11, which is really higher than all of these except one. All right, but let's come back to that. So the deviation, in order to calculate that, we need to look at how each individual score differs from the mean. So the mean is the average of all the sentences. You can see the formula in Excel is just the word average, and in parentheses the range of cells, so B4 to B8. So the average sentence length. The deviation takes each individual score, and you can see we are taking the individual score and subtracting the mean sentence. Right? So that's 11. So you can see B4 minus 11. We could also, if we wanted to, instead of putting the number 11 in there, we could add the cell reference, which is B10. And you get the same thing. Okay. So when we include a cell reference, we're saying use the value that's in that particular cell. So now when we put in the reference, if we change the value, this will automatically update. If we have a number in it, it doesn't automatically update. We have to manually change the number. All right. So I'm going to go ahead and just update all of these to have the cell reference instead of the value. There we go. So those formulas now only have cell references. So these are the deviations, so how each sentence deviates from the mean. So prisoner 1 is 7 years less than the mean. Prisoner 2 is 6 years less than the mean, so on. Prisoner 5 is 29 years more than the mean. Then the squared deviation is just taking this value and squaring it. So you can see the formula for that. It's saying the cell reference is C4, and then to square it, we have that caret sign, which says it's an exponent, and then the number 2 says 2 is the exponent. We're squaring it, so we'll square it. And if you're filling this out, you could just copy that formula and paste it into these remaining cells. But you can see we just need to update the cell references to tell Excel what we're squaring, and then we have the sum of the square deviations here, which is 841. Okay, so now we have the mean sentence, and then what's the variance? The variance is the average of all of the Sorry, we don't have the sum there. We didn't calculate the sums. So what we're doing, the variance is the average of the square deviations. So we're just taking, and we have the formula for an average, and then we're just looking at this range of values here for that average. And so we can see the variance is 210.8, right? So the average of the square deviations. Standard deviation is just the square root of the variance. So you can see the formula for that is SQRT. So equals SQRT, and then the cell reference for the variance, which is B11. Right? So we're taking the square root of what is in B11, and that's 210.8. Okay, so that gives us the standard deviation of 14.5. So that's how we get a standard deviation from a set of values. This last sheet shows us position, range, and something called the IQR, which is the interquartile range. Right, so we have in this problem, it says on a scale designed to measure tolerant attitudes towards immigration, 2 college classes scored as follows. Find the range quartiles and IQR for each class. So in class A, those are the scores, and for class B, those are the scores. So let's say 1 is intolerant and 6 is very tolerant. So you can see the range, the minimum score is for class A a 1, right? If you just look at those values, you see the lowest score is a 1, and the maximum score is a 6. Okay, so that's what the highest score is. See, the range is a little shorter here, right? So it just goes from 1 to 4. So to calculate the range, you just subtract the minimum from the maximum. So in this case, B12 minus B11. And then over here, it's C12 minus C11 because we're working in the C column. All right, and in order to get the quartiles, usually start with the median. I know it's a little bit out of order. Let's just start there. Again, the median is the middle value, but when you have an even number, you have to take the average of the two middle values. So let's remember to use our order of operations here. And that's important, as we saw before. So the median is going to take the two middle values, B6 plus B7, and make sure to put those in parentheses, and divide by 2. Right? So it's the average of those two scores. All right, so the median is 1.5, and that was for class A. For class B, the median is 2.5, so the average of 2 and 3. Okay, so then when you're looking at the first quartile, you're looking at what is the middle score between the median and the lowest value. So if you look at the score between the median is somewhere between rows 6 and 7 here, and the lowest value, we have three scores here. So we have 1 as the middle score, right? For class A, and then for class 2, the middle of the first 3 there is 2. And then for quartile 3, we're looking at the middle of the lower half of the distribution. So Q3 is a 4 for class A, and then for class B, it's 4 also. So the interquartile range is subtracting, that's Q3 minus Q1. All right, so you can see we have Q3 minus Q1 there, B16 minus B14 for class A. For class B, it's C16 minus C14. So we can see interquartile range is bigger for class A, as is the range. So there's more variability in the attitudes for class A than for class B. But the overall, the measure of central tendency, class B looks to be more tolerant on average when we look at the median compared to class A. So less variation, slightly more tolerant. And that's basically what the conclusion says there. So that's how we work with Position, as you know, quartiles are one type of position. We can also look at percentiles, deciles, quintiles. It's just taking a distribution and carving it into different intervals, right? Okay, so that's what we're doing. And we call those fractals, by the way. Thanks for watching.